Today, in this example, we are going to discuss about the line coding techniques, so which is very important form of the coding. So the first one, we can define a line coding, it, like it is defined as the process of converting binary data to a digital data. For example, if we better understand the line coding, we can explain it by giving an example. Binary data, you can write the binary data in a digital format like 0 1 0 1 1 0 0. If you insert this binary data into a line coding, then the output will be a digital signal. So, for example, so this zero is represented with a pulse zero, which is having a amplitude either zero or a. So, if the data is zero, then you can see there is a no signal. If the data is one, then there is a amplitude a signal. If zero, then again zero. If it is one, then it is amplitude is positive a, again one, then the again amplitude is positive a, zero, then the amplitude is zero, then again zero, then the amplitude zero. So it means that zero will represent a zero level and the one will represent the a level. So this shows the translation of a binary data into a digital signal. So this is known as a line coding technique. So, the line coding technique has a few important characteristics. The first one is signal level and data level. The second one is pulse rate and bit rate. The third is DC component. Fourth, self synchronization. So, turn by turn, we are going to explain each characteristic. The first characteristic is signal level and data level. What does that mean? Signal level means the number of values allowed in a particular signal, and data level the number of values to represent data. So if we write an example to explain the signal level and data level, the example can be in this format, like the binary data has two levels. Usually either it is 0 or it is 1. So like you can say the data is 0 1 0 1 0, and you can write the signal level for each data bit. For 0 you can see it's a 0, for 1 it is a amplitude a, for 0 it is 0, for 1 it's amplitude again a, and then for 0 it is 0. So this shows that you are going to represent your data by two data level, like either it is 0 or either it is 1. And similarly, you can see there are two signal level as well. The first level is a 0 and the second level is a. So two data level, so that is 0 and 1, and a two signal level, that is 0 and positive a. But in the second example, you again have a 0, 1, 1, 0, and then 1. But you can represent this type of data with another signal level. So where you can see you can have positive a, 0, and negative a. So 0 represents 0 level, 1 represent 1, and the next one represent negative a, then 0 represent 0, then 1 represent 1. So this shows that you have two data level, either 0 or 1, but you have three signal level is 3. So you have positive a, 0, and negative a. So two data level, but signal levels are 3. Similarly, the second characteristic was pulse rate and bit rate. So we can explain the pulse rate and bit rate like this. The pulse rate is defined as the number of pulses per second, and pulse is the minimum amount of time required to transmit a symbol. And the bit rate is the number of bits per second, For example, if one pulse corresponds to one bit, then pulse rate equal to the bit rate, of course. But if pulse carries more than one bit, so in that case you cannot say that the pulse rate is equal to the bit rate. Then the pulse rate is lower than the bit rate. So this can be better understood by giving an example. For example, we can define a bit rate which is equal to the pulse rate multiplied by log 2 to the L. So L is basically the levels. So if you have L is equal to 2 raised to the power m, so where m is the number of bit per sample. So for example, if L is more, bit rate is more, like if you increase the L, then if you increase L, so the log 2 of L will be increased. So it means that the pulse rate will the bit rate will be increased. But if L is equals to 2, then we know that log 2 of 2 will be equals to 1. So pulse rate multiplied by 1 equals to the pulse rate. And in that case, the pulse rate is equals to the bit rate, which is only possible if M is equals to 1. So it means that the number of bit per sample, if you have one number of bit per sample, so in that case your bit rate is equals to pulse rate. But if you have more number of bits per sample, then your bit rate is bigger than the pulse rate. So we can write like this: the bit rate is equals to the pulse rate multiplied by m as well, because m is equals to, we know that we can calculate, so m is equals to log 2 to the power l. Okay, so that is why we can write pulse rate multiplied by m. So if one sample is represented by multiple bits, then the bit rate is greater than the pulse rate, which is understood. The third characteristic is DC component. So this is very important. Over one cycle period of a waveform, if all the positive voltages are cancelled by negative voltages, then DC component of the waveform is zero. So it means that you have positive level as well as negative level. So if we have positive level and that positive level will be cancelled with the negative level, then the DC component will be zero. But sometime you don't have the negative level, so it means that there will be a DC component, because there you don't have the DC level over there. So for example, we can give more explanation for this, like in a line coding, the signal with non-zero DC component is treated as distorted one, and it can create error in received signal. The signals with a DC component cannot pass through a transformer, hence signals with DC components 0 are preferred. So this is another important point to remember for the DC component. For example, if you consider this signal, so this signal level, you can see the data level is 2, 0 and 1, but the signal levels are 3, positive A, 0 and negative A, but you have data level either 0 or 1. So if 0 is given, so you can see it is represented minus A, but if it is 1, it is represented by positive A, so 0 negative A. So if it is 0 negative A, if it is 1 positive A, so it means that the negative value is cancelled by the positive value. So that is why you can say there is a 0 DC component. But in another example like this one, so you can see if it is a 0, then the level is 0. If it is 1, then the level is plus A. If it is 0, then the level is 0. If it is 1, then the level is plus A. So you can see there is a positive DC component. So it means that the average value is not always a 0. So that is why it is usually preferred to use a component with 0 DC component. The fourth characteristic was the self-synchronization. What is self-synchronization? If the receiver bits interval corresponds exactly to the sender bit interval, only then it is possible to receive an error-free signal. So that is usually required that you should be perfectly synchronized and you should have a better exactly the same clock pulse on the receiving side if you want to exactly extract the information or retranslate the signal. So the clock frequency of the transmitter and receiver should be same if you want to do perfect modulation. If the clock frequency are different, then the data at transmitter and receiver will be different, or you can say that there will be an error. So, to match the data at the transmitter and receiver, clock frequency must be same and synchronized. This can be better understandable by giving an example. For example, this is the transmission side and this is the receiving side. So at the transmission side, when you have 1 and 0, 1 and 0, on the receiving side, at same time you have 1 and 0, 1 and 0. So it means that the criteria is that the bit interval should be same. And the second criteria is that they should be synchronized. But another example, so if it is 0 1 0 1 at the transmitter side, but on the receiving side you can see when it was 1 on the transmitting side, it is 0 on the receiving side. When it was 0 at the transmission side, it is 1 on the receiving side. So it means that there is a delay. So due to this delay, error occurs. So that means that the system is not synchronized. So in order to remove such errors, the system must be synchronized. So that is the basics of line coding. So I'm going to end this session here. So I hope that you understand the line coding basics and its important characteristics. But if you still have any question, you are most welcome to ask. Thank you for watching the video.